professor at UMass Amherst, and we're working together on some projects. But I'm going to hand it over to you, Andrew.
All right, thanks, Neil. Yeah, so I think so Neil was great given all of this great talk about crowdsourcing, and I think what we have done so far can clearly have a lot of ties into it. So Neil has primarily been focusing on crowdsourcing from teachers, and I think our work recently can be sort of seen as crowdsourcing from students themselves. Yeah, there are a lot of works in this area, but I'm just gonna give like a quick overview about what we have done. Right, so let me see, can I go to the second? Okay, great. Yeah, so our main goal in this work is that since there are a lot of ways.
And Andrew, just to be clear, you're not in full presentation mode.
Yeah, that's kind of like the. Let me see. So can I?
Okay, it's okay. If you wanted to be in that mode, fine.
Let's see. Yeah. Hang on just a second. Is this okay or?
Yeah, you got it in a funky. We're seeing you.
Yeah. This is like a 2-screen setup, so maybe I'll just stick to this. Yeah.
Fine.
Yeah. So really, there are multiple ways of learning, and learning through verbal interactions with teachers is really time-consuming, and it's good for students, especially during problem solving, and when they have negative affect in particular. But the problem is the teacher really can't do this to every student at the same time, simultaneously, which means that number one, the teachers are overburdened with a lot of, they have a lot of burden. And number two is students also, they are stuck in this slow and insufficient feedback cycle. Right, so what we do is one possible solution to this is to create virtual teaching assistants. And these really just mean automated pedagogical agents that can really not, the way I think about it is we're not trying to replace anything. We're not trying to replace teachers, but on the other hand, on the contrary, we're trying to help take away tasks that machines can do, so that they can focus and use more of their time on stuff that's actually important, that's actually really dependent on humans, and that's what we're hoping, which is to build a system to support teachers rather than try to replace anybody. Yeah, and virtual teaching assistants, there has been some recent success, and especially this thing built by a group of people at Georgia Tech called Watson. This is built on IBM's Watson system, and then essentially an AI that answers student questions in a discussion forum. But the thing is, it's still very basic, and we think that before it can become a reality, there needs to be a lot of significant advances in AI, so that it has to satisfy 3 requirements. So number one is it has to be comprehensive, right? Because it must decide whether to automatically answer a question or defer to the core staff, because for several different reasons. And the most obvious reason is just that some of these student questions are simply not answerable by a machine. You would have to expect that the human can answer it. And it would be smart for an AI algorithm to realize that this is a time that we should just ask to defer it to the teachers. And then the second requirement is that it has to be aware of the context. Because even if a virtual TA can actually answer every possible question, I don't think you would want it to do that, because having students to discuss among themselves and forming and finally arriving at the correct answer is actually good. There are a lot of people saying that that's very beneficial to learning. So we'd have to make a decision on that. And there are some works on analyzing the dynamics and discussion forums about how people interact with each other, and including some of our prior work, which analyzes using discussion forum posts to discover the dynamics in posts, people's behavior, and also the interest of different students in posting in different topics. And then the third focus is conversational. It has to be conversational because it can't just spit out meaningful words. It has to engage in meaningful conversation with the student. And I'm not going to talk about that because that's just, that has been the focus in this research field for many years up till now. All right, so our contribution is essentially to look at automatic answering of frequent and repetitive logistical questions that arises in online discussion forums. Why do we focus on logistical questions? Because number one, these are very redundant and the information is there, either answered by somebody before or announced by the course instructor already. And it's usually, it's a burden for TAs and instructors to answer them over and over again. This thing always comes up. Nobody really browses these things. I mean, if you're in class, you know that. And our framework really has a couple of different parts. Number one is you start by scanning through all the relevant course documents, and these documents include not only the lecture notes and all the course textbook, but also they include logistical emails, these announcements that people send out, and also prior discussion forum texts, posts, and satisfactory answers. So I think that links up nicely to Neil's point of crowdsourcing, because essentially now we're crowdsourcing previous correct answers and adding them into the repository of stuff that we can provide to students who ask this new question in the future. Yeah, and we're really using a sort of simple framework. So it consists of two parts. Number one is you separate all the course documents, you separate them into chunks, and then build a document pool for you to retrieve relevant documents that contain a possible answer to this particular question that's asked. And then we use an automated question answering method to extract short and textual answers. And in addition, we use an answerability classifier to sort of help us to decide whether this question is actually answerable, and when it's not, hopefully potentially deferring to humans. And what the data that we use is actually local, which we collected in a UMass undergraduate physics class, introductory class. And it's a pretty large class with more than 2,000 posts throughout an entire semester. So this is what we tested on. And you can see that we divided these questions into different types. So about 20% are logistical questions, which are actually, probably more than you think. There are a lot of conceptual questions, reasoning questions, and some of them are just not answerable. And in this work, we focus in particular on logistical questions because most of these are factual, and because automated question answering methods so far can mostly only answer factual questions. And what we did was we compared our system with several different baselines. So number one is those answers provided by core staff. We recruited core staff to rate all of these answers and see which one is satisfactory, which one is not, and which document is relevant to the student question and which one is not. We also compared with the IBM Watson system, and the result is, we can outperform these other methods. You see, Watson is really inflexible in this case. It's not really able to extract meaningful, relevant documents and provide satisfactory answers. And we are not doing as well as humans, of course, but sometimes we're a little bit more robust than humans, just because human TAs do not really answer every question that's out there. So we're definitely not better, but we have more coverage. And again, this is a visualization of what's going on. So you can see using an answerability classifier, you can sort of vary the threshold of which questions you choose to answer, and in terms of precision and recall. And we are just comparing against humans and the IBM Watson system. So let me show you a couple of examples of what's going on. So, for example, for this particular student questions that's been asked, what we do is we can extract a piece of relevant course documents. So this is essentially the lab syllabus. And then you can extract this and also extract a short text band for the answer. So these are just positive examples of satisfactory answers. And you see that they come from different sources. It can even be a course document provided by instructor, which is the lab syllabus, or for past the discussion forum posts. This answer has been rated as satisfactory. And we had to do some tweaking on our document retriever, but in the end, it sort of worked out and can help us retrieve a healthy blend of both instructor provided things and student generated things. But there are also cases where this thing does not really work out. So you see in some cases, you really extract irrelevant documents. But in some cases, you retrieve very relevant documents, but the short answer span that you sort of detect is just off. Right? These are things that we will improve on. And also you can apply this to factual questions, but since this is a physics class, there are only a total of 18 questions all semester that are factual. And we can sort of do reasonably well. But in terms of coverage, that's just not a lot. And I'm just going to skip this part. Let me see. So yeah, I think there are a lot of cool works that can come as a follow-up to this. And I think Neil and I are exploring a lot of these interesting new directions. And specifically, some of the things that we are looking into are see whether there are, for these content-based questions that are more reasoning and stuff, instead of automatically answering that, if we know that that's not possible, can we at least extract relevant course documents and to recommend to the students for remedial studies before they, to help them to rethink about their question. And especially in the case when the student question contains multiple modalities, including, for example, both text and math. If it's a mixture, how do you retrieve relevant course documents? That's an interesting topic. And also, we want to be able to not just use like large-scale these NLP tools that are trained on large-scale text data, but also adapt to student-generated text. Because if you have answered some student questions on discussion forum before, you probably realize that these 20-year-old kids, the way they talk is just entirely different from the way people write on Wikipedia. So you'd have to adapt to this data set for sure. And also, we want to do something with misconceptions. I think that would be really awesome, although we're not sure of the details yet. So before I hand back to Neil, I would like to just mention that we have a paper here on knowledge tracing, which is a classic topic in educational data mining and AI ed. And what we've done in this paper is that to show that despite a lot of recent efforts on using deep learning to improve predictive accuracy, we actually showed that traditional models, things that are like IRT and other stuff that are inspired by cognitive theory, they still have a place in today's AI ed world, because we showed that by combining these attention networks with IRT models, you can actually not only outperform deep learning based models, but also give you some excellent interpretability in your models. And that's it. And thanks to all the organizers and Neil. And yeah, so I'll hand it back to you. Neil, you're muted, it seems.